Let's talk about how we could set up a circuit that consists of two resistors in series and then an LED also in series. So here we're showing the breadboard, and I've got the positive part of the power supply coming in here and energizing this rail along here. This is all going to be sitting at whatever my power supply is. Then I've got a jumper wire coming over here to row 3 on the breadboard. And so row 3 is going to be sitting at whatever my positive power supply is. And then our resistor goes into a hole in row 3 and goes all the way down to, it looks like, row 11. And then in row 11, in another hole, I have the second resistor, and it comes down here to row 21. And then in another hole in row 21, I have the LED, which comes over here, it looks like, to row 26. And I have a little small jumper wire going over to this row along here, which I've got attached to the negative terminal of the power supply. So this entire board, the row along here that is closest to the blue line is at ground. And so if I turn on the power here, so let me turn on, say, 6 volts, you can see that the LED lights up and it's working. And then if we wanted to measure some of the voltages in the circuit, we would use a voltmeter here. So on the voltmeter, or our digital multimeter in general, there's a lot of different things we can measure. We're going to stay away from where it says, where you have the ampere symbol. We're going to stay away from measuring the current. HFE is for testing transistors, and we'll talk about some of these others later. This is for AC voltage. We're going to come over here to the area where it has the V and the horizontal line. This means DC voltage. What these numbers mean is the full scale value of whatever you're going to measure. So if you're measuring a very small voltage, you're going to want to be down. Say you're measuring a volt and a half, you might think you put it on 2, and that would normally be right, but I've found that it doesn't measure on this kind of cheap voltmeter. So I'd put it on 20. I'd keep pretty much everything on 20. We're never going to go above 20 volts. We're always going to be living between really up to 10 volts. So I just set it to 20 volts. Again, these numbers are the full scale value of the DC voltage that you can, of your scale. And then just I mentioned here also that if I turn this over to where it has the ohm signal, our ohm image, I can measure resistances. So typically we have resistances of a few hundred ohms, so we'd put it over here at the probably the 2K if we were to measure resistance. So let me first use this device to measure and check what my supply voltage is, my source voltage. So what's the voltage between this positive rail, energized rail, and this ground rail over here? It's supposed to be 6 volts, but it's a nominal 6 volts. So let's take it and let's see, put it on 20. And then I'm going to take these leads here and just put them across the breadboard like this, directly into the power rails. And you can see that I measure 6.05 volts, so pretty close to 6 volts. So that one's pretty accurate. And if I want to measure the voltage drop, say across the first resistor here, I would take one connector and put it there into row 3, and the other connector and put it in here to row 11. And you can see that I'm measuring about 2.5 volts. Of course, you can calculate what it should be, assuming some voltage drop across the diode using Ohm's law. And now let me measure the voltage drop across the second one. So I'm just going to move them down there. And it's a little less. That tells me that this resistor is lower in resistance. think that's a 220 and that's a 330. And then if I want to measure the voltage drop across the diode, I just put the probes across the diode like that. You can see it's about 2 volts, 1.90 volts. And using this technique, we can measure, any of the voltages that occur in this circuit. All right, I think we'll stop there. Thanks for watching.